Okay, just picture this absolute silence. You're on a spacewalk floating 400 kilometers above our planet. You go to grab a handrail, and your glove just slips. In the total vacuum of space, there's no air, no friction, nothing to stop you, and you just watch helplessly as the International Space Station starts to drift away. First an inch, then a foot, then a meter, and it's not coming back. So what happens now? This is pretty much NASA's worst-case scenario. And it's a situation that isn't just terrifying. It's this brutal, unforgiving lesson in the laws of physics. So what actually happens next? Well, here's the cold, hard truth of it. You're now a human satellite. The second you disconnect, you stop being an astronaut on a mission. You literally become an object in orbit, a tiny, lonely satellite with a clock that is ticking down fast. Let's just look at the numbers here, because they really paint a grim picture. You're hurtling along at over 17,000 miles per hour, but relative to the station, you're just slowly drifting away. You've got about 8 hours of oxygen, which sounds like a lot, but your radio's down. There's no way to call for help. It's just you and the void. Now, if we want to understand how you could possibly survive this, we first have to get our heads around why it's so incredibly deadly. And the answer is all in the physics. Physics that goes against every single instinct you have from living here on Earth. It all comes down to this. Newton's first law, an object in motion stays in motion. If you accidentally pushed off the station with even the tiniest bit of force, you are now going to keep moving in that direction forever, unless some other force acts on you. There's no air up there to slow you down, you just keep going. Think about it. Here on Earth, you can swim through water. You can even sort of flail through the air to create a little bit of movement. But in a vacuum, there is absolutely nothing to push against. If you try to swim back to the station, all you're going to do is spin around helplessly. And this is where things get really, really weird. It's the paradox of orbital mechanics, and it's a total mind bender. Your gut instinct, your Earth brain, is screaming, "I've got a tool. I'll throw it away from the station to push myself back." Makes sense, right? Nope. It's the exact wrong thing to do. If you throw it forward in the direction you're already orbiting, you actually speed up. And speeding up raises your orbit, so you drift up and away. Okay, so what if you throw it backward to slow yourself down? You think that would work, but no. You drop into a lower orbit, which is actually faster. It's insane. Every single instinct you have is wrong. So when every law of physics is working against you, when every human instinct just pushes you further into danger, survival isn't going to come from making the right move. It has to come from having the right tool. And thankfully, NASA thought about this nightmare scenario and built a lifeline into every modern spacesuit. It's called SAFER. It stands for Simplified Aid for EVA Rescue. And it's pretty much exactly what it sounds like. It's a tiny personal spacecraft, a jetpack, with 24 little thrusters. And it's designed for one purpose and one purpose only, to get you back to that station. But, and this is a huge but, there's a massive limitation. It runs on pressurized nitrogen gas, and you've only got 1.4 kilograms of it. That is a terrifyingly small amount of fuel to work with when your life is on the line. And what does that tiny amount of fuel get you? It translates to a total change in velocity, what rocket scientists call delta V, of just 3 meters per second. That is it. That's your entire budget for saving your own life. 3 meters per second. And this is the scariest number of all. You get one shot. With that little fuel, there are no do-overs. There are no second chances. You have to pull off a perfect rescue on your first and only attempt. Okay, so you've got this one shot with almost no fuel and absolutely zero margin for error. Executing this rescue is like a delicate, high-stakes ballet of pure precision. So the very first thing you have to do is stop your spin. You can't navigate if you're tumbling through space. But just getting yourself stable, getting yourself pointed back at the station, that alone can burn through up to 30% of your precious fuel, and you haven't even moved an inch closer to safety yet. All right, the spin is stopped. You're facing the station. But all that time, you've kept drifting. You're now 100 meters away. That's the entire length of a football field, with just enough fuel left for one last push. The maneuver has to be flawless. First, a short, controlled burst from the thrusters to start moving toward the station. Then you shut them off and just coast. You let Newton's law do the work for you this time. And then, as you get close, you use the final precious wisps of nitrogen to brake, to stop yourself perfectly right at the handrail. So that's it. That one single three-step maneuver determines everything. And it only leads to one of two starkly different endings. If you pull it off, if you do it perfectly, your glove closes around that cold metal handrail. You feel that solid connection to the station. You're safe. The nightmare is finally over. But if you miscalculate, if you use just a tiny bit too much fuel to accelerate, or you fumble the braking burn, the fuel runs out. The hissing stops, and you just drift right past the station with absolutely no way to ever get back. You are now officially space debris. And what happens in those final hours is just haunting. You wouldn't freeze instantly, that's a movie myth. The vacuum is an amazing insulator, so you'd stay warm inside your suit for hours, just alone. You would watch the Earth spinning below, seeing a sunrise and a sunset every 90 minutes. And your end would come quietly when the carbon dioxide scrubbers in your suit finally failed, and you'd just drift off. Months later, your orbit would finally decay. You'd re-enter the atmosphere, burning up in a brilliant, silent streak across the night sky. A final, lonely fate. A shooting star that no one wished for. It's just a sobering reminder that up there in space, engineering isn't just about discovery. It's about foresight, and it's about building that one last line of defense, because sometimes it's the only thing standing between an astronaut and the infinite void.